What if the most powerful food system ever built wasn't modern? What if it wasn't industrial? What if it was ancient?
More than 2,000 years ago, farmers built living ecosystems that produced fish, eggs, and fertilizer from a single body of water.
No chemical inputs, no imported feed, no fragile supply chains. Just balance, just biology, just design. And it worked for centuries. So why don't we use it today? Why was it replaced by systems that demand constant inputs, constant expansion, constant extraction? Was it inefficient, or was it simply too independent? If nature already solved protein production, why did we choose a more complicated path? Tonight, we uncover the system history quietly buried. What if, more than 2,000 years ago, long before machines and chemicals, farmers discovered how to create food that nearly fed itself? No synthetic fertilizers, no industrial feed, no diesel engines, just water, sunlight, and life. This was traditional Chinese polycultural aquaculture, a system built not on control, but on balance. Not a farm separated into pieces, but a living system where every organism had a role. For centuries, it quietly fed villages, Majin, without exhausting the land. And today, as the world questions industrial food systems, this ancient design is being rediscovered. As early as 475 BC, written records described integrated fish farming in remarkable detail. These farmers were not guessing. They were observing nature carefully, season after season. They understood something simple. Nature wastes nothing. So they designed their food systems to follow the same rule. They didn't rely on one species alone. They relied on many. Each species fed in a different layer of the pond. Koi fish feed at the surface, tilapia feed in the midwater, catfish feed at the bottom. Grass carp grazed on vegetation, to converting plants into protein. Silver carp filtered plankton from the water column. Bighead carp thrived in mid-water, capturing suspended nutrients. Common carp worked the bottom in recycling organic matter. Because each species occupied a different niche, competition was minimized. The result was extraordinary efficiency from a single body of water. Surface life, midwater life, bottom life, all producing simultaneously. This was not just fish farming, it was ecological stacking. By combining fish, plants, and water, we create a self-sustaining ecosystem, maximizing productivity while restoring the environment. But the system didn't end with fish. Ancient farmers added another layer of life. Ducks were not confined. Then, they were natural foragers. They cleaned the surface, consuming insects and excess plant growth. And as they moved, they fertilized the pond naturally.
what modern systems call waste, this system called fuel.
Duck manure stimulated plankton growth, the foundation of aquatic life.
Billions of microorganisms worked invisibly beneath the surface, converting ammonia into nitrates. Through the nitrogen cycle, harmful waste was transformed into nourishment.
Aquatic plants absorbed excess nutrients, preventing imbalance. Some of these plants were astonishingly rich in protein. Fish consumed these plants, turning sunlight into edible protein.
Ducks fed on them too, completing the cycle.
This was not a straight line of production. It was a circle.
Sunlight powered plant growth. Plants powered plankton. Plankton powered fish. The more balanced the system, the more it regulated itself. External feed inputs were minimal, sometimes unnecessary.
This was biological intelligence, not mechanical control.
Surface, water column, sediment, shoreline, all producing at once.
This was not just farming. It was a living engine of renewal.
From a single pond came fish, eggs, vegetation, and fertilizer.
But the world began to change, and so did agriculture.
The Industrial Revolution transformed how food was produced. Efficiency became defined by scale, not balance. Farms specialized. One species, one product, one output. Animals were separated from land. Land was separated from water. Nutrients were no longer cycled, they were imported. Chemical fertilizers replaced biological fertility. The circular systems of the past became linear systems. In linear systems, waste accumulates, polluted runoff entering river from large farm. Efficiency was measured in output per machine, not harmony per ecosystem. Research funding shifted toward industrial models. Documents stamped Modern Agriculture Initiative. Policies favored centralized, export-driven production. Complex integrated systems were harder to standardize. Polyculture ecosystems resisted mechanization. Mechanical arm pauses over diverse pond, unable to operate. Small, diversified farms struggled to compete in commodity markets. Small farmer looking at expansive industrial competitor. Integrated pond systems were labeled traditional, not modern. They were not outlawed, but they were deprioritized. Yet in rural regions, the practice never fully disappeared. Knowledge passed quietly from generation to generation. For decades, this system slept beneath the surface of modern agriculture. But in recent decades, the world began asking new questions. What happens when supply chains falter? Empty grocery shelves, slow pan across missing products. When feed and fertilizer prices rise sharply, farmers face mounting bills and tough decisions. What happens when soil loses its life? Cracked dry earth dissolving into degraded farmland. What happens when climate patterns become unpredictable? Unpredictable floods can devastate crops and infrastructure. This volatility often leads to prolonged for culture and ecosystems are profound. In moments of uncertainty, people look backward for wisdom.
Researchers began studying traditional polyculture systems again.
The pond samples show promising results.
The biodiversity is much higher than in modern systems.
This could inform new sustainable practices.
They found something remarkable in the water sample, a thriving, healthy pond ecosystem. Polyculture ponds often produced stable yields with fewer inputs. Diversity reduced disease outbreaks and system collapse. When one species struggled, others compensated. Fish, eggs, aquatic plants, fertile sediment. Food production didn't need to be massive, it needed to be local. Even today, a scaled-down version can be built in a backyard. Start with water, deep enough for stability. Cross-section showing 3 to 6 foot depth design. First, introduce aquatic plants. Small duckweed floats on the surface. Next, add water spinach for structure. This creates a healthy habitat for fish. Allow the microbial community to establish, time-lapse of water clearing and ecosystem stabilizing. First, add a golden fish. Then, a blue fish to keep it company. Finally, a striped fish to complete the group. A balance forms in the pond. Only then do the ducks enter. They swim cautiously, finding their place. This system rewards patience, not shortcuts. In colder climates, adaptation is essential. Hardy species like carp and bluegill endure freezing winters. Depth protects life when surface water freezes. In this cross-section, the deep pond pocket maintains liquid water, allowing fish to survive beneath the frozen surface. In warmer climates, growth accelerates.
Tilapia and fast-growing plants can multiply rapidly.
But every region has rules, and ecosystems deserve respect. Responsible stewardship ensures harmony with surrounding environments.
This system is not copied blindly, it is adapted thoughtfully. But its core principle remains universal.
Diversity strengthens systems. In this thriving wetland, diverse species interact to create a resilient ecosystem. Each organism, from birds to plants, contributes to the system's overall strength.
Balance creates stability. Nature thinks in circles, not straight lines. Linear systems break under pressure, factory assembly line halting abruptly.
But living systems regulate themselves.
Sunlight becomes plant. Plant becomes plankton. Plankton becomes fish.
Abundance does not always roar. Sometimes it ripples quietly.
For 2,400 years, this design endured wars, dynasties, and revolutions.
And now, in an age of uncertainty, it feels relevant again.
The question is not whether it works. History has answered that.
The question is whether we are willing to rebuild what was quietly set aside.